Engineering 305, Chapter 3, Section 5 and 6 on strain transformations. The course learning objectives for this section are that I would like you to be able to perform strain transformations so that we can understand the state of strain at a point in a different coordinate system. This will involve finding the maximum and minimum strain and the orientation of the maximum and minimum strains. We will also want to be able to use Moore's circle to perform strain calculations. If this looks familiar, it's because it's exactly like what we did in the previous chapter with stress, but now we're doing it with strain. The equations from the study guide that relate to this section are the strain transformation equations, which from the study guide, out of the book, it's which reduces to, and then we have equations 37a, 37b, 38a, and 38b, which are, they look very similar, except that we lose the double angle portion, or we lose a factor of 2 for the shear strain. We still have two, that 2 would be right here. We still have two different versions of this. One is this cosine squared version, and then the other is when we converted it to the double angle and then we did some further simplification. You can see that there. There are two equations also following exactly the same. There's two equations following the shear. There's the one that we could derive somewhat straightforward, and then there's the double angle version that shows up below. So the equations from the study guide continue. We've got the principal strain equations, and these also look like the principal stress equations. That angle, you'll remember there was a 2 up top here when we had shear stress and normal stresses below. We've lost that 2. We've lost that factor of 2. And it shows up as a factor of 1/2 here. So if we look, this looks the same, this looks the same, that looks a little different. So, and you'll see that really in the next slides, because that's what we're doing in this chapter. I don't want to derive these equations from scratch. We could spend a lot of time, but we want to be able to work with these equations. And at this point, you guys are very capable of being able to work with those. So as our comparison, here's our normal stress equation. The normal stress is equal to the normal stress in the x cosine squared theta, normal stress y sine squared theta, plus 2 times the shear stress sine theta cosine theta. This is where we've lost that 2 again. I'll just point that out. That's the thing that needs to be emphasized for this chapter, because these equations are very similar. They're very similar. Here in this, because I'm missing that 2 here, it becomes 1/2 there. Similar down here, the double angle had gamma, the shear, this is now the shear strain is equal to, and there's a 2 there that is missing here. And what that does is that if we divide this whole equation by 2, you get gamma, the shear strain divided by 2 would equal to a negative difference of the shear stresses, which shear strains, sorry, tongue twisters here. The negative difference of the shear strain, sine theta cosine theta plus, and then this would have a gamma over 2, that shear strain over 2, which is different here. So it would be the shear strain in the n direction over 2 is equal to that term. You can see it. It's just go through the substitution, spend your time thinking through it. Same thing here. You can see where that 2, I'm missing a factor of 1/2. That's, yep, it's right there. Okay. The principal equations, the equations for the angle at which the principal strains take place, and then the subsequent equations for the principal strains, all are changed by that factor 2. So I'm missing it here. where it had showed up there before. And now I've got my shear strain over 2, where it was just shear stress. That's the theme that just continues throughout. That's the only difference. It's a factor of a 2. But that totally messes up Moore's circle. Where with Moore's circle, we were plotting the normal stress and the shear stress. We're now plotting the normal strain and the shear strain divided by 2. Otherwise, this is all the same. Once again, I'll show you the equations. Now we just, in some ways, I say we work with the equations. We can still do Moore's circle, or we can actually go to websites and solve these equations also. But that's the core of this chapter. Same as last time, same as with the stress chapter. We're just going to work with the equations, and we do this, and we do our strain transformations in this chapter. And then we've got additional tricks that we're going to do in the next section. And the reason for that is we can't measure stresses, but we can measure strains. So now that we can measure strains, that will lead us to be able to do some other things. And we'll play with that in the next section. So the next problem, the next example that we're going to do is example problem 3.4 on strain transformation, and then we'll do problem 3.5 on principal strains. And then it looks like I said I was going to do problem 347, which is Moore's circle for strain. I'll probably solve that not only by hand or with a picture, but I'll also solve that with a strain calculator. And then we'll move on to the next section. See you in class.